All right, guys, for this one, the graph got a little tricky just because there's so much information in this graph. But you should know that it's a bar graph. And the reason you should know that is for this reason right here. Your x-axis is going to be groups. And anytime you have groups, it'll be a bar graph. Now, notice that the groups are not continuous, meaning it's not like height. So because of that, it's literally a bar graph and not a histogram. So your bars should not touch because it's not a continuous grouping. So then on the y-axis, you have percent of cells that have differentiated. Now you have 3 different cell types that you are looking at. You're looking at a neuron, a muscle, and skin cells. And so you have 3 different colors. Then on the y-axis, like I said, you have your factors. So factor A, B, C, and then we had some combined. Don't forget to graph your control as well. So the control is the one that didn't get any kind of factor specifically. So when you do the graph like this is what it should look like. Hopefully your graph looks similar. Because I can't really think of another way to do it. I suppose you could do it with a dot here instead of a bar graph, but really this should be a bar graph. For the questions, let's go over the questions next. With the questions, the first one says, identify which transcription factor most strongly promotes neuron differentiation. So you're basically going to go through each cell type and determine the factor. And looking at this graph, it's very obvious. This data is pretty easy to look at. So neurons are definitely A, muscle is going to be B, and then skin is going to be C. And if you're looking for... it's probably going to ask you, give me some data or some evidence to justify this. You can go a couple different ways. Obviously, the first set of data you want to use is just the factor by itself. So obviously, factor A, you had about 70% of the cells differentiate, whereas when it was in factor B or C, it was pretty similar to the control. So there really wasn't a difference for factor B or C when it came to neurons. You can also talk about when you combine it with the others. A, B, and AC both were a little bit lower. They were just under half, but you still saw some neuron cell differentiation there. Whereas when it was B and C, there was very little differentiation and it was very similar to the control. So for all 3 of the cell types, that is kind of what you would use for your evidence. So you would talk about the factor alone, talk about the factor when it's combined, and which combinations still show differentiation, and then talk about which factors did not create differentiation. So that's your evidence. Then it asks you to compare TFA alone with TFA and B combined. So here what we're looking at, if you look at A, so A, let's just talk about neuron cells. You can see we have a pretty good growth for neuron cells. If I look at A and B together, it drops. So really what you can talk about is the fact that adding factor B could be inhibiting the growth of neuron cells. But if you look at A and C, same thing is happening. As long as A is there, we're getting almost half of the cells differentiating, but it is lower than when it's factor A by itself. So it's possible there's some competition going on. Could also be that because you have a second factor that is going to differentiate other cells, that the machinery is being taken up by that factor. The last question says, predict the effect of a new transcription factor, which would be D, that activates neuron development if you add that with transcription factor A. So for example, you would continue your graph, and I would have a TFA plus D. Let me erase that and make it a little bit more legible for you. Sorry about that. Okay, so if I'm going to have A and D. Obviously with A, we're still going to be up higher than 40%, because even with A and B and A and C, we were at 40%. If D also increases neuron cells, we would probably be up above 70%. We probably would not be at 100%. I don't believe that it's possible to differentiate all cells, but we would be probably higher than A by itself. So that would be the answers to that homework. I hope that helped. And there's a question at the end of your homework where you are going to reflect on what you got wrong and how you would have done this differently. Thanks, guys. Have a good day.